So in that case, we can start with transfer learning. To be honest, the rest of the course is going to be about transfer learning. And a major portion of deep learning is just transfer learning, where you do some pre-training on a related task, and then you're going to fine tune on your target task. And why would you do that? Because usually you have a lot of data, or you can generate a lot of data for a task which is as simple as image classification. Or if you're doing natural language processing, it's very easy to define a task which is next word prediction or next character prediction. You can train your model on these generic tasks where you have plenty of data, and then you can try to adjust them and fine-tune them on a task that has less data. So that's the big picture. So transfer learning is not going to end with these slides. It's going to be the entire course in front of us from this point on. But to get an idea of how things are going to work, let's start with this paper. This was an assignment for you to watch. Any questions about it? Here you are transferring from ImageNet to ImageNet. So it's nothing special, and you are transferring from the same task to the same task, which is classification to classification. And you have the same number of labels in the end. Or they could actually change when you're doing different tasks here, man-made versus natural split. But that's the big picture in terms of transfer learning. You learn something, some weights on task A, and then you're going to copy those weights here. The rest of them you're going to not randomly initialize for your task B, and then train them. You have two options. Fix these to a TensorFlow.stop gradient on these weights so that they don't adjust, and only train the rest of your neural network, or let those earlier parameters to adjust as well. This is the big idea transfer. And then to be systematic, the paper is working with self-error as well. What if those weights and biases that you trained are coming from the same data? And then you do the same thing here. What is going to be the difference? What are the impacts? Any questions about this? And you start to see some nice patterns. The later layers, if you do transfer, are going to end up being task-specific. They're going to depend on task A, and then they're less transferable. But as you go earlier in your neural network, those features are going to end up being more transferable. There is also a nice phenomena happening here that throughout the optimization, all of these layers, all of the weights and biases are co-adapting. If you change them, if you change a portion of them and keep the other ones fixed, then you're going to end up with a suboptimal model because all of these weights and biases were co-adapting throughout the training. And then the other two curves are when you're actually freeing up those parameters to fine-tune. And then they're going to give you better performance because then your weights are going to again start to co-adapt, or they're going to start to transfer. Any questions about this before I move on?